we have to describe the phenomenon of length contraction. If you remember that every observer must measure c to be constant. They will disagree, however, on a period of time, and they will also disagree on length. Remember this situation with a bike. The light comes from the bike. The speed of the light is the distance it travels in that time that it takes. However, if it's moving forward, it means the light could be going faster, but it's not going to be going faster. It means for this bike, a smaller period of time would have taken place. His clock goes slow. It also means his length will be shorter. And it has to be this way if we're going to agree on the speed of light being a constant. And as Maxwell said, the speed of light depends on the permeability of free space and the permittivity of free space, and not on the frames of reference of the people that are observing the light. So it travels this distance, we measure the light as passing through this distance, but the guy on the bike, only measures it as passing through that distance, which means if the distance is less and the time is less, then we will agree on the speed of light. Define proper length. An observer measures proper time if an event, the start and the end of an event, happens at the same point relative to the observer. A proper length is when the length of an object as measured by an observer who is at rest relative to the object. So if the object is at rest relative to you, no matter how fast you're going, you will still measure the proper length. So we have two frames of reference here, Paul in the first frame of reference, Mary in then another frame of reference, which is moving relative to Paul's. So we're looking from Paul's point of view. Who is measuring the proper length? Well, this length, the arm's width between A and B for Mary, will always be the same no matter how fast she's going to her. So she is measuring the proper length. Paul's measurement of this length will depend on the speed of Mary. So they do not agree. The Lorentz factor is used to calculate what the observed length is relative to the proper length, and the observed length is equal to L0 divided by the Lorentz factor, or in other words L0 times by the square root of 1 minus v squared over c squared. It means that Paul will measure the length AB to be smaller than Mary's measurement. Mary measures the proper length, so since he will measure it as being smaller, that's why it's called length contraction. So we have to solve problems involving length contraction. We have a 10-meter rocket which passes by at 10% of the speed of light. The proper length is 10 meters because the rocket is at rest with respect to itself, obviously, but the rocket moves with respect to us. So what will we measure? The length of this rocket is going to be the original length, the proper length, L0, divided by the Lorentz factor. The Lorentz factor is 1 over the square root of 1 minus v squared over c squared. So how do we measure this? So this is a rocket. We need to find out what what we measure this 10-meter length to be. It will be a little bit less. In fact, it will actually be 9.95. So you could try to calculate that and see if you end up with this answer. What happens if it goes faster? If it goes at 90% of the speed of light, its length will be contracted. It's around half the size of it was before. What happens if it goes at 99% the speed of light? It gets contracted even more. So we reckon that it will be 1.41 meters long. So try these three calculations to see if you end up with the same answer.